Air conditioners pull heat out of your house, but dump it outside, making the world a bit hotter. How can a machine turn hot air into cool? Every time you hit cool, something is happening inside that turns warm into chill, and it's all about a tiny liquid turning gas and back again. Inside the unit, a compressor squeezes low-pressure refrigerant into hot vapor. That vapor rushes through copper tubes to a condenser coil outside. Fans blow air over the coil, pulling heat from the gas and cooling it back into liquid. The liquid then drops in pressure at an expansion valve, turning cold again before entering the evaporator inside your home. Here, warm indoor air passes over the cold coils, giving up its heat to the refrigerant. The cycle repeats, moving thermal energy out, while keeping your living space comfortable. Cooler air back into the living space. Thus, the house temperature drops while the outside remains unchanged, illustrating effective heat transfer. Pause 0.8 first. We meet the refrigerant, a fluid that moves through the system. It starts as a low-pressure liquid inside the evaporator coil. When it absorbs heat from your room, it turns into vapor. This phase change is called evaporation and releases latent heat. The vapor then travels to the compressor where pressure rises dramatically. Higher pressure pushes the temperature up, making the gas hot. In the condenser coil, that hot gas gives its heat to the outside air. As it cools, it condenses back into a liquid, dropping in pressure again. The low-pressure liquid passes through an expansion valve, losing energy. This drop in temperature prepares it for another round of evaporation. The cycle repeats continuously, keeping the indoor air cool. Thus, refrigerant's ability to change states is essential for efficient cooling. Pause 0.8. The compressor is the heart of the cooling system. It pulls in cold, low-pressure refrigerant from the evaporator. Inside the compressor, pistons or a scroll squeeze the gas. Squeezing raises its pressure and turns it into a hot vapor. The high-pressure heat travels through copper tubes to the condenser. Here, the system releases that heat to the outside air. Heat emission from the compressor is visible as a faint glow. This hot vapor then condenses into liquid before returning to the evaporator. The cycle repeats, continuously pulling indoor heat and expelling it outdoors. Thus, compression turns low-pressure gas into high-pressure heat that drives cooling. Pause 0.8. The compressor pushes refrigerant into a closed loop, raising its pressure. High-pressure gas travels through the condenser coil toward the outside. Air fans blow cool air over the coil, absorbing heat from the gas. As heat leaves, the gas temperature drops sharply. The cooled gas becomes a dense, high-pressure liquid. Tiny water droplets form on the coil's surface as condensation occurs. These droplets evaporate into the air, carrying away latent heat. The released heat is expelled into the outdoor environment. Thus, the indoor space remains cooler, while the outside warms slightly. This continuous cycle repeats, maintaining a steady temperature inside. The condenser's metal surface conducts heat efficiently from the refrigerant. This external heat transfer keeps the indoor air at a comfortable level. Pause 0.8. The expansion valve sits between the condenser and evaporator coils. When high-pressure refrigerant reaches the valve, it is forced through a narrow orifice. This sudden constriction causes a rapid pressure drop in the refrigerant. Lower pressure means the refrigerant's boiling point falls dramatically. As a result, the liquid refrigerant begins to evaporate inside the indoor coil. Evaporation absorbs heat from the surrounding air, cooling it instantly. The refrigerant now becomes a cold vapor that continues through the evaporator. A pressure gauge on the low-pressure side shows a sharp drop to about 30 psi. This dramatic change is what makes the indoor coil feel like an ice box. The expansion valve's precise control ensures the refrigerant never freezes inside the coil. Thus, the cycle continues with low-pressure vapor returning to the compressor. The compressor then pressurizes it again, restarting the refrigeration loop. Pause 0.8. The evaporator coil sits inside the air handler. Cold refrigerant flows through its thin tubes at low pressure. Warm indoor air blows across the coil, touching the cold surface. Heat from the air moves into the refrigerant by conduction. The refrigerant absorbs this heat and begins to vaporize. As it evaporates, its temperature stays constant while pressure drops. This phase change pulls thermal energy out of the room air. Consequently, the indoor air cools and feels more comfortable. The now warm vapor travels back to the compressor for compression. The cycle repeats, continuously removing heat from your living space. Thus, the evaporator coil is the heart of indoor cooling. Pause 0.8 first. The compressor squeezes low-pressure refrigerant into a high-pressure gas. That hot gas then travels to the condenser and releases heat to the outside air. After cooling, it becomes a dense liquid that passes through the expansion valve. The valve drops its pressure sharply, turning the liquid into a cold, low-pressure mixture. This cool mixture enters the evaporator inside the house and absorbs indoor heat. As it warms, it turns back into vapor and returns to the compressor to start again. Each cycle repeats automatically, pulling heat from your living space continuously. The system stays balanced because pressure differences drive the refrigerant's motion. Heat is transferred out of the home, while the refrigerant cycles through the loop. Thus, the air conditioner keeps the indoor temperature steady and comfortable. Pause 0.8. An air conditioner uses a refrigerant that cycles through compression, condensation, expansion, and evaporation to transfer heat from inside your home to outside. This continuous loop keeps indoor air cool while releasing heat externally.